Okay, I'm starting on Form B with short answer number 1. Please find it on your test. In which quadrant is the point xy located if x is positive and y is positive? So in every coordinate plane, we have 4 quadrants. 1, 2, 3, and 4. If x and y are both positive, it's going to be in quadrant 1. Quadrant 2 is going to be a negative positive, negative x, positive y. Quadrant 3 is a negative x, negative y. And quadrant 4 is a positive x, negative y. So if x is positive and y is positive, the answer would be quadrant 1. That should have been your answer. The next question, translate the triangle below 3 units to the left and 2 units down. Draw the image of triangle A prime, B prime, C prime on the same graph below. All we had to do here, it didn't even ask for the coordinates. All they wanted you to do was take each point. So we start with A, count 1, 2, 3 to the left and down 2, and we call that point A prime. Remember, when we translate a point, it keeps the same letter, but we just call it a prime. We go to point B, 1, 2, 3, 1, 2, make a point, B prime. Same thing with C, and we're doing the same translation for all 3 points. 3 to the left and down 2, and that would be C prime. And then we just connect the dots to get our new translated triangle. That was all there was to that one. All right, graphing linear equations. There's a couple different steps to graphing linear equations using a table of values, which is the way that we do this. If you see the word linear equations, that means line. Right here, see the word line in the word linear? That means we're drawing a line on our graph. It's not a triangle, it's not a point, it's going to be a full line, which means we need to find the points that are going to make up this line. So we start with a table of x and y values, x and y. We choose any values we want for x. I like to choose negatives and positives and 0, because you need to draw the whole graph, not just the graph in quadrant 1. So I'm going to start with negative 6, 0, positive 3, and positive 6. What we do with those values is we take them and plug them into this equation here for x. We do that for every one of those values. So we're going to start with y equals 2/3. In place of the x, I'm going to put my first chosen value of x, which is negative 6, plus 4. 2/3 times negative 6, multiply and then divide, right? So 2 times negative 6 is negative 12, divided by 3 is negative 4, plus 4. Negative 4 plus 4 is 0. So y would equal 0 for x equals negative 6. And that's going to be the first point when we get to our graph. I don't know how to pause this. Hold on. Here we go. Okay. So now we plug in the 0. Y equals 2/3 times 0 plus 4. 2/3 times 0 is 0, plus 4 is 4. Y equals 4. Do the same thing for 3. Y equals 2/3 times 3 plus 4. 2/3 times 3 over 1 is 2, plus 4 is 6. Y equals 6. And the last one, y equals 2/3 times 6 plus 4. 2/3 times 6 is 4, plus 4 is 8. Y equals 8. So now we have 4 points. Negative 6, 0, 0, 4, 3, 6, and 6, 8. We take a piece of graph paper, draw a coordinate plane, and we're going to graph those points on our plane. Get it where you can see both of them. So y, x, negative 6, 1, 2, 3, 4, 5, 6, 0. Here's our first point. 0, 4, 0, 1, 2, 3, 4. There's our second point. 3, 6, 1, 2, 3, 1, 2, 3, 4, 5, 6. And 6, 8. 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8. And then you can take a straight edge, side of a piece of paper or a ruler, and they should make a perfectly straight line. Connect the dots, arrows on both ends of the line, and that's your answer. Yes?
How many points will be taken off?
Okay, I'm not going to do the next one because it's the exact same process. You just choose any 4 values for x, a negative, a positive, and 0, and you plug them in. Y equals the opposite of x, negative x plus 2. Okay? And then you would plot those points on the graph and connect the dots with a line and draw arrows on either side of the line. Number 5. Is the triangle with the sides 1.7 inches, 1.1 inches, and 2 inches a right triangle? Explain. In this chapter, we learned that there is a rule that applies to all right triangles. It's called the Pythagorean Theorem. And if a triangle is a right triangle, it will fit into the Pythagorean Theorem. The Pythagorean Theorem says that a squared plus b squared equals c squared. A and b are the legs, the short sides, and c is the hypotenuse, which is the longest side. So the only way that we can be sure that this is a right triangle would be to plug the sides and the hypotenuse into the Pythagorean Theorem and see if it comes out true. We can't just draw this on our paper, because on our paper we can't identify the correct angles. We can use a ruler to measure the lines, but we can't identify the correct angles. You could draw 1.7 and 1.1 this way, and that's not necessarily a right angle. You could draw it as a right angle if you had a protractor or something to draw it with, and then try and measure. That's not accurate. Okay, the only sure way to know if something is a right triangle is to use the Pythagorean Theorem. So we plug in our sides for A and B, 1.7 squared plus 1.1 squared, and our hypotenuse for C. And we find out if this is true or not. You can use a calculator to work out these values. So in my calculator, put this on the screen here, I would do 1.7 squared is 2.89 plus 1.1 squared is 1.21, and 2 squared is 4. So now we would add these together and see if they equal 4. 2.89 plus 1.21, it doesn't. It equals 4.1. 4.1 does not equal 4. Therefore, the answer is no, this is not a right triangle because it does not fit into the Pythagorean Theorem. Okay, when we plug in the legs and the hypotenuse and work it out, they're not equal. No Pythagorean Theorem, no right triangle. All right, moving to the next page. Number 6. Triangle ABC has vertices of A, -1, -2, B, -4, -4, and C, -3, -5. Remember, it's a triangle, so we want to connect the dots. Graph triangle ABC, I just did, and its image after a reflection over the x-axis. The axes are labeled, guys. There's no reason why you should have done this over the y-axis. It says x-axis right there. It's the horizontal one. Okay. Name the coordinates of the vertices of the reflected triangle. So we're going to reflect this up over the x-axis up here. Point A is 2 below, so we're going to go 2 above, and that's going to be A prime. And they want us to name the coordinates of each point. This is at -1, +2. -1, 2 is the coordinate. B is 1, 2, 3, 4. So we're going to go 1, 2, 3, 4 past it. That's B prime. And the coordinates are -4, +4. And C is 1, 2, 3, 4, 5. So we're going to go 1, 2, 3, 4, 5. That's C prime. And its coordinates are -3, +5. Connect the dots, and you have your reflected image with the coordinates of the prime vertices. Okay, number 7. The formula V equals the square root of 64h. 64h means 64 times h. V is the velocity in feet per second of an object that has fallen h feet. Find the velocity, so we're looking for V, of an object that has fallen 75 feet. We're going to plug in 75 feet for the h, the height. So V equals the square root of 64h. We're going to plug in 75 for h, so 64 times 75. Again, pull out your calculator. Okay. 64 times 75 equals 4,800. Square root of 4,800. Again, in your calculator, you already have the 4,800 there. You just have to hit the square root key, which is second, and x squared. 4,800. 69.28. The question says round to the nearest tenth, so we're going to round to 69.3 feet per second. There's your answer. That one's just substitution and solve. The next two are about lines of symmetry. And if we remember, a line of symmetry is a line that we draw through an object on which we could fold the object in half and it would be an exact mirror. The two halves would be exact mirrors of each other. So I have a duplicate image here, and what we're looking for is some line on which we can fold that image in half and the two would line up. And if you can see through that paper, I don't know if you can or not, you can see they don't line up there. They don't line up here. They're going in different directions. See it when I open it up? If we go through the corners, they definitely don't line up. Okay, there's nowhere that we can fold this image where the two sides would be perfect mirrors of each other. See, the top here is smaller, the bottom is larger. They're not exactly the same. So this shape had no lines of symmetry, so we would have written none. The other shape, if we were to fold it in half this way, we could fold it exactly on top of itself. If you look through the paper, let me hold it up in the light maybe. No, it's hard to see. And when we unfold it, we have two exactly the same halves. Okay? They line up exactly onto each other. So our line of symmetry for this one would have been right through here, and that was the only line of symmetry. Okay, moving on. I'm going to skip the bonus question. Number 11, write the Pythagorean Theorem. We just went over this for the previous question about the right triangle. The Pythagorean Theorem is a squared plus b squared equals c squared. That is the Pythagorean Theorem. And then it says, for which type of triangle is this equation true? It is only true and always true for right triangles. So the complete answer would have been a squared plus b squared equals c squared, and for right triangles only. Alright, number 12. Triangle PQR has vertices at 1, -2, 7, -3, and -3, -8. The triangle is translated 6 units down and 3 units to the left. Find the coordinates of P prime, Q prime, and R prime. You did not have to graph this. If you did graph it, that's okay, as long as you also gave me the coordinates, because that's what the question was asking for. But you don't have to graph this. If you remember, we can write a rule for a translation. 6 units to the left would be x minus 6. 3 units down would be y minus 3. That's our rule. Now we just apply that rule to each of the points. P is 1, -2. So P prime would be 1 minus 6, because it's x minus 6, which is -5. And y would be -2 minus 3, which is also -5. So there's your P prime, -5, -5. Q prime. Q was 7, -3. So 7 minus 6 is 1. -3 minus 3 is -6. And then R prime. R was -3, -8. -3 minus 6 is -9. And -8 minus 3 is -11. There's your 3 new points. And if you had graphed it and translated it, you would have gotten the same 3 points. Number 13. Triangle ABC has vertices 0, 2, 4, 3, and 2, 6. Triangle. Graph triangle ABC and its image after reflection over the line through -3, -2, and -3, +2. It says the line that goes through those 2 points. Remember, a line is infinite. It goes on forever. So you would draw the whole line. They just gave you 2 reference points to show you where to draw your line. Now we're going to reflect that triangle over that line. A is 1, 2, 3. We go 1, 2, 3. That's A prime. B, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. B prime. And C, 1, 2, 3, 4, 5. Notice I'm stopping at the line that we're reflecting over. This is the line of symmetry. 1, 2, 3, 4, 5. C prime. And they wanted you to name the coordinates of those 3 points. -6, 2. negative 10, 1, 2, 3, and negative 8, 6. Make sure you're reading all the instructions and doing every step, guys. Okay. This one is about a rotation. Remember, a rotation is where we hold on to the origin and rotate the paper around, right? So there's our 90-degree counterclockwise rotation. That's what we're looking for, 90 degrees counterclockwise, which means a quarter turn to the left. What I would have done is take a piece of paper and traced this graph. Call this one my y and this one my x, because now that's up and that's horizontal. Then we go back to our original graph, and now we can see the rotation. See it? The R came to here, the S came to here, the P comes around to here, and the Q to here. There's my 90-degree rotation. R prime, S prime, P prime, Q prime. See? 90 degrees that way. All right. Number 15 just said to graph these 3 points on the same coordinate plane. Some of you, it was a little confusing. Some of you graphed it up here. If you did it correctly, that's fine. I gave you credit. It should have said on graph paper. So we'll just draw an axis. Okay. And our first point, A, was negative 3, 2. From the origin, 1, 2, 3, and 1, 2. Positive 2. That's A. B was 1, negative 5. Positive 1, negative 5. 1, 2, 3, 4, 5. There's B. And C is 5, negative 1. 1, 2, 3, 4, 5, down 1. Make sure you use your X first and then your Y. And you did not have to connect the points. The question just said graph the 3 points. It didn't say graph triangle ABC, right? So that was your answer right there. Okay. Find the 2 square roots of 121. Every number has a positive and a negative square root. 121 is one of our perfect squares. If you didn't remember, you could have put this into your calculator. Second, x squared gives you a square root symbol. 1, 2, 1, and we have 11. So our roots are 11 and negative 11. 11 times 11 is 121. Negative 11 times negative 11 is also 121, so the answer was B. This is another translation question. What are the coordinates of the point 4 to the left and 5 above the point 1, 0? So the translation, 4 to the left is x minus 4. 5 above is y plus 5. We apply the rule to the point. X minus 4, 1 minus 4 is negative 3. That rules out A and B, and D, actually. So let's just make sure that our y is correct. 0 is our y. Y plus 5, 0 plus 5 is positive 5. Absolutely. The point is negative 3, 5. Okay. This one was a multiple choice question where you had to choose the correct graph. We're looking for the graph of the point D, negative 3, negative 4, and its image after a reflection over the y-axis. So point D was at negative 3, 1, 2, 3, negative 4, 1, 2, 3, 4. This is the correct point D. This one is at negative 4, negative 3. That one's not right, so it couldn't be that one. This one's in the right place, so this is possible, and this one's in the right place. So we know it's not B. And we're looking for a reflection over the y-axis. Again, the axis is labeled. This is our y-axis here. So we're looking for a reflection over the y-axis, which would be directly to the right. This one is a reflection over the x-axis. This one is a reflection over a line that goes through here. It goes that way. Okay, so the only correct one was A. That was your answer. Moving on. This is a right triangle question. As soon as we see a right triangle question, guys, you should have the Pythagorean Theorem in the back of your mind. Now, this was one of the hardest questions on the test. There's always going to be one that's really hard because that's, you know, if you get 100, that means that you absolutely know this stuff inside and out. This was the test. This was the hard question, okay? But we're going to work through it. The City Commission wants to construct a new street that connects Main Street and North Boulevard as shown in the diagram below. The construction has been estimated to cost $100 per foot. To the nearest dollar, estimate the cost for building the street. So we know that from here to here on North Boulevard is 9 miles. That's one leg of our right triangle. From here to here on Main Street is 4 miles. That's the other leg of our right triangle. So we can use the Pythagorean Theorem to find the length of the new street. A squared plus b squared equals c squared. My legs are 9 and 4, and then the length of my new street would be c squared. So 9 squared is 81, 4 squared is 16, equals c squared. Okay, so we can go to our calculator if you're not comfortable squaring things. I could have done 9 squared, the x squared key, right there, plus 4 squared gives us 97. Okay, so 97 equals c squared. And then we would want to take the square root of both sides to find c. Okay, so square root of 97, we get a big decimal number. So hold on to that because we're going to need it. Okay, keep it in your calculator. We have, this is in miles. If you notice, we were given measurements in miles. So our new street is 9.8488858 miles. But the cost is given per foot. So the first thing we have to do is make a conversion from miles to feet. And it tells you 1 mile equals 5,280 feet. So we need to take this number in our calculator and multiply it by 5,280 to get the number of feet. 52,001.96919 feet. Okay? And then it says $100 per foot, so we multiply again by $100. We get 5,200,190, rounded up to the nearest dollar, $197. So our answer was D. Okay? Again, you just have to go step by step by step. Write a rule that describes a translation of a point from -4, -2 to -1, -1. So we look at our x's first. We're going from -4 to -1. You have to ask yourself, do I add or subtract to get from -4 to -1? If you think about a number line, -4 is here, -1 is here. So we're getting greater, so we're actually adding. We would be adding 3 to get from 4, -3, -2, -1. So it's plus 3. So x plus 3 would be the first part of our rule. So it's not going to be C or D. Those are wrong. Then we look at our y's to get from -2 to -1. Here's our -2 on the number line. So again, we're adding, and we're just adding 1. So it should have been y plus 1. So there's your answer. Okay. 6, how many lines of symmetry does the figure below have? This is like our folding questions again. For a rectangle, there's one through the middle here, and there's one through the middle here. You could fold it in half on either one of those lines and get a mirror image. However, if you fold a rectangle through a diagonal, you don't get a mirror image. You get something that looks kind of like this. Okay? It's not a mirror image. So there are no diagonal lines of symmetry in a rectangle, only in a square. All 4 sides have to be equal for there to be diagonal lines of symmetry. So the answer was just 2, the horizontal and the vertical lines of symmetry. Okay, and that was the entire test. So I'm going to stop the recording there.